Hello dear students, good morning. Welcome to interactive virtual class Nagaland once again. I hope all of you are well. Alright students, so in today's class we will revise on another chapter. Okay, let us see. So here we see a mother and a daughter visiting a fruit shop. Yes, let's see what they buy from here. Okay, so here we see that they bought some fruits. Yes, what are the fruits? Here we see some banana, grapes, apples, some melons. Yes. So they bought some fruit from the fruit shop. Now again here they are visiting a vegetable shop. They have the cucumber, they have the capsicum. Okay. Here the daughter is telling her mother, "No mom, I hate these vegetables. They are bitter." Okay, they are bitter. Then the mom replied saying, "But Ria, they are good for your health." Okay. Then the daughter asks her mother saying, "Mom, why do oranges and grapes taste very different from bitter gourd and methi?" Okay. So here we see that orange, okay, oranges, grapes, okay, these are sour in taste, but the methi and the bitter gourd are bitter in taste. Yes, students. Orange and grapes are sour in taste, whereas methi and bitter gourd are bitter in taste. Yes, there are some fruits which are sour in taste. There are some vegetables which are bitter in taste, right? So why is this so? Okay, why are some fruits okay sour in taste, and why are some vegetables bitter in taste? What is causing this sourness or bitterness in these fruits and vegetables? Okay, it is because these fruits contain acids. Okay, these fruits contain acids, and these vegetables contain bases. Okay, and these vegetables contain bases. That is why they are sour in taste and these are bitter in taste. Okay, so in today's class we will discuss about acids, bases, and salts. Okay, we will revise on this chapter, acids, bases, and salts. Now we have seen that some fruits, yes, like grapes, yogurt, gooseberry, tomato, lemon, and tamarind or imli. Okay, all these fruits that we see here have sour in taste. Yes, it is because they contain acids. Okay, so different acids are present in different fruits and vegetables. So this is one way, okay, to determine or to check whether a substance contain acid or whether a substance contain base. If the taste is sour, then it means it contains acid. If it is bitter in taste, that means it contains bases. Okay, so these grapes or gooseberry or tomato or lemon, they contain different acids. Okay, and that is why they are sour in taste. The acids in this substance are natural acids. Okay, the substance or the acids that are present in these fruits that we can see here, like grapes, tomato, lemon, gooseberry, okay, the acids present in these fruits are natural acids because they occur naturally in nature. Okay, so let us see some sources and types of acid. So in lemon and orange, citric acid and ascorbic acid are found. In tamarind, okay, tartaric acid is found or is present. In vinegar, okay, acetic acid is present. In curd or yogurt or dahi, lactic acid is present or is found. In gooseberry, ascorbic acid is found. In apple, malic acid is found. And in green tea, tannic acid is found. In banana, folic acid is found. So these are some of the sources. Okay, these are some of the fruits or items or substances. Okay, and these are the types of acid present in these substances. Now when we look at this chart, we see that the acid which are present in the fruits, okay, or the vegetables, They are natural acids because they occur naturally in, occur naturally in nature. Now recall, let us see types of bases. Let us see some types of bases. So in lime water, the types of base present is calcium hydroxide. Okay. In window cleaner, the types of base present is ammonium hydroxide. And in soap, the type of base present is sodium hydroxide or potassium hydroxide. And in milk of magnesia or an acid, the type of base present is magnesium hydroxide. So these are some of the sources and these are some of the type of bases. Okay, so we have seen acids and bases. The first thing we discuss is acids are sour in taste, bases are bitter in taste. Okay, so let us answer the first question for today. Please get your rough devices ready, students. The question is, which of the following substances taste bitter? Okay, I'm giving you 15 seconds for this question. Your time starts now. Which of the following substances taste bitter? Option A is acid, option B is base, option C is salt, option D is none of this. Alright, students, your time is up. Yes, very good. The correct answer is option B, that is base. We have seen that we can identify acids or base by their taste, right? Acids are sour in taste and bases are bitter in taste. So here the correct answer is option B, that is base. Very good, students. Now, indicators, okay? Now, there are so many acids and bases that we can found, that can be found or that are present, but we cannot taste every acids and bases with our mouth to get the taste to identify whether it is acid or base. Yes, because some acids are dangerous to us, some bases are dangerous to us. So for every acids and bases that we can found, we cannot identify them by their taste. We cannot identify them by their taste. So to identify acids and base which we cannot taste, we use indicators. So what are indicators? Let us see. Indicators are chemical substances that indicate if a given substance is acid, base or neutral. Neutral means neither acid nor base. So indicators are chemical substances that indicate if a given substance is acid, base or neutral. Synthetic indicators are those indicators made by man. So let us see natural indicators. What are natural indicators? Let us see some. So some of the natural indicators include litmus. Litmus, turmeric, or haldi. Yes, turmeric. Then we have the China rose. We have the red cabbage. So these are some of the example of natural indicator. Using this we can identify whether the given substance is acid or base. So let us see the first one, litmus. Litmus is a natural dye and litmus is extracted from lichens. You must have seen this, yes, on the bark of the tree. So litmus is a natural dye and it is extracted from lichens. Lichens gives a mauve purple color in distilled water. Distilled water is neutral. So it gives purple or mauve color in distilled water. So this is the color of the litmus in neutral solution or in distilled water. It is available in the form of a solution or in the form of strips of paper known as litmus paper. So litmus is present in the form of a solution known as the litmus solution. And it is also available in the form of paper known as the litmus paper. You must have seen this. Yes, we have blue litmus paper and red litmus paper. So Litmus is available in the form of solution known as litmus solution and also in the form of strips of paper known as litmus paper. So let us see, okay, what happens. So when litmus solution is added to an acidic solution, it turns red. Okay, so take a solution and add some drops of litmus solution. If the solution turns red, it means acid is present in this solution. This solution is acidic. Okay, when litmus solution is added to a solution and it turns blue color, it means that this is a base. Okay, or it is a basic solution. So here we see that by using litmus solution turns red in acid and it turns blue in base. So by identifying this color, we can identify whether the given substance is acid or base depending on the change in color when we add litmus solution. Okay. Now let us see litmus paper. Okay. Now when we look at this beaker, okay, it contains hydrochloric acid and this contains sodium hydroxide. Yes, students, test tube. Okay, in this test tube, it contains hydrochloric acid, which is acid in nature, and in this test tube, it contains sodium hydroxide solution, which is base in nature. So now we see that when we dip blue litmus paper into hydrochloric acid, it turns to red. Now in bases, when we dip red litmus paper, it turns blue. Okay, so from here we see that acid turns blue litmus to red and base turns red litmus to blue. Okay, so from here we can see that we can identify acid or base depending on the change in color of the litmus paper. When the litmus paper, there are two types of litmus paper. One is the blue litmus paper and one is the red litmus paper. In acid, the blue litmus paper will change to red, and in base, the red litmus will change to blue. So we can identify acid or base by using litmus paper. Okay. Another natural indicator we have is turmeric. Yes, turmeric or haldi. Yes, students, have all seen this, right? We use it at home. Now, we see here a woman washing clothes. Okay, you can also try this at home. When you cook your curry using haldi and you get stain on your cloth, okay, when you wash with soap, you will see that there is color change. Okay, there is color change. Let us see why. Okay, so soap is basic in nature. Yes, turmeric changes the color of basic solution to reddish brown. So you stain your cloth with a curry which was cooked using turmeric or haldi. Okay, now when you try to wash your cloth using soap, you will see that the color, yellow color, will change to reddish brown. Okay, it is because the soap is basic in nature. So here we see that turmeric, when you add in acid solution or in acidic substance, there will be no color change. Okay, no change will be observed. But when you add turmeric into base solution, you will see that the color of the substance or the color of the solution will change to reddish brown. So in this way, we can identify acid and base using turmeric. In turmeric, in acid, turmeric, even if we add turmeric, there is no change. If we add turmeric in base, it changes to reddish brown color. Okay, let us see another indicator, natural indicator, which is the China rose. Okay, so this is the China rose. Take these petals. Okay, take the petals of this China rose, grind it and make it into a solution using water. Okay, so here we have China rose in warm water. Okay, make a solution of the China rose in warm water. Then take 3 test tubes. First is the hydrochloric acid. This contains hydrochloric acid. This contains sodium hydroxide and this contains salt solution. Now when we look at this, hydrochloric acid is acid, so this is acid. The first test tube is acid. The second test tube contains sodium hydroxide, which is base, and the third test tube contains salt solution. This is neutral. So let us see what happens. Okay, when we add China rose, the China rose solution in these 3 test tube. Let us see. So here we see that when we add, okay, the China rose solution into acid, it turns into dark pink or magenta. Okay. In base or the sodium hydroxide, it changes the solution to green color, and in salt solution it will have no effect. Okay, so from here we can see that when we use China rose in acid, the solution will change its color to dark pink or magenta. In base, the solution or the substance will change its color to green color. So by using China rose, we can also identify, okay, acids and base, or we can also indicate whether the substance is acid or base by using China rose. Okay. Alright students, another indicator is red cabbage. Okay, red cabbage. So let us see. Okay, we have three beaker here. The first beaker contains red cabbage solution. The second beaker contains red cabbage in acid, and the third contains red cabbage solution in base. So here we see that when we add red cabbage in acid, it turns red in color. Yes, and when we add red cabbage solution in base, it changes to green color. So from here also we can conclude that, or we can identify acid and base by using red cabbage solution. When you add red cabbage solution in acid, it will turn to red, and when you add red cabbage solution to base, it will turn to green. Okay, so this is how we can identify acid and base by using the natural indicators. Okay, alright students, we have another question. Please get your rough devices ready. The question is, litmus is extracted from, okay, we have four options. I'm giving you 15 seconds to respond to this question. Your time starts now. Yes students, litmus is extracted from, option A is curd, option B is grapes, option C is lichens, and option D is cabbage. Alright students, your time is up, and yes, very good, the correct answer is option C, that is lichens. Litmus is a natural dye and it is extracted from lichens. Very good students. Now we have this, so far we have discussed about natural indicators. Yes, the lichens, the litmus, then we have the China rose, we have the turmeric, we have the last one we discussed was red cabbage. Now we have discussed about the natural indicators. Let us see synthetic indicators. Okay, so synthetic indicators include phenolphthalein and methyl orange. So these are synthetic indicators, these are man-made indicators. Okay, so these indicators also we can use to identify acids and base, okay, or to indicate whether the given substance is acid or base. So first let us see phenolphthalein. Okay, here we have acid in the first beaker, then in the second beaker we have base. Okay, this is phenolphthalein. Now let's see what happens when we add a drop or two of phenolphthalein into acid and base. So let us see. Add one drop of phenolphthalein in the acid solution and into the base solution and stir it. Okay, now what happens? What do we observe here, students? Yes, we see that there is no change in acid, right? Phenolphthalein, even if we add phenolphthalein in acid, there is no change. But when we add phenolphthalein into the base solution, it changes to pink color. Yes, so from here we can say that phenolphthalein in acid is colorless and phenolphthalein in base is pink color. So this is how, by using phenolphthalein, we can indicate whether the given solution or the given substance is acid or base. Alright students, let us see more. Synthetic indicator, okay, or methyl orange. Another synthetic indicator is the methyl orange. Let us see. Take a beaker, okay, two beaker, one containing acid and one containing base. Now when we add a drop of methyl orange, what changes do we observe here, students? Yes students, we see that the acid solution changes to red color and the base solution changes to yellow color. So from here we can see that methyl orange in acid will change to red color and methyl orange in base will change to yellow color. So we can also use methyl orange to indicate whether the given substance is acid or base by observing the change in the color. Okay. Now let us perform an activity here. Take hydrochloric acid in both the test tube. Okay, take hydrochloric acid in both the test tube. Let us take litmus paper and see. Okay, we have seen that in acid the blue litmus paper turns to red. Yes. Now what about the red litmus paper? What is the effect of red litmus paper in acid? Let us see. So when we put the red litmus paper into the acid, we see that there is no change. Okay, so from here we can say that the blue litmus paper changed to red in acid, but the red litmus paper has no change in acid. Okay. Now take phenolphthalein, okay, and add in acid. We see that there is no change in acid. Yes. Now take methyl orange and add into hydrochloric acid. We see that it turns red. So from here we can see that there is no change, okay, or phenolphthalein is colorless in hydrochloric acid. Methyl orange is red color in hydrochloric acid. That means phenolphthalein is colorless in acid and methyl orange is red color in acid. Okay. Now let us take two test tubes again containing sodium hydroxide. Okay, and take both red litmus paper and blue litmus paper. We have seen that in base the red litmus paper changed to blue, right? But what about the blue litmus paper? Okay, what is the effect of blue litmus paper when it is put inside the base? Let us see. So first we see that the red litmus paper changes to blue in base. Now when we put the blue litmus paper into the base, we see that there is no change. Okay, so from here we can say that in base the red litmus paper changed to blue, okay, but the blue litmus paper has no effect in base solution. Okay, another example what you can do here is take sodium hydroxide again in two test tube, add phenolphthalein. We see that the solution turns pink. So phenolphthalein is pink in base. What about methyl orange? What happens when we add methyl orange into the test tube containing base? We see that it turns yellow. So here we see that phenolphthalein in base turns to pink and methyl orange in base turns to yellow. Okay. So activity. Repeat this activity with sulfuric acid, nitric acid, acetic acid, calcium hydroxide, potassium hydroxide, magnesium hydroxide and ammonium hydroxide. So this contains a list of acids and bases. Let us see, okay, how the color changes. So we have the sample solution in the first column, then we have the effect of red litmus paper. In the second, blue litmus paper, phenolphthalein, methyl orange solution. So let us see. Take hydrochloric acid. It is an acid, so we see that the red litmus paper has no effect on acid. The blue litmus paper will change to red. The phenolphthalein is colorless in acid. Methyl orange, in methyl orange it will turn to red. It is because this is an acid. Okay, let us see next. Sulfuric acid. We will observe that there is no change with red litmus paper, but the blue litmus paper will change to red color. There is no change when we add phenolphthalein into sulfuric acid, but the methyl orange, when we add into sulfuric acid, it will turn the solution to red. Nitric acid, okay, in red litmus paper it has no effect. Blue litmus paper will change to red. No changes in phenolphthalein solution, and methyl orange solution will turn nitric acid into red color. Acetic acid, red litmus paper has no effect. The blue litmus paper will change to red. Phenolphthalein, there is no change. Methyl orange will turn the solution to red. Sodium hydroxide, we see that the red litmus paper will change to blue color. There is no effect by the blue litmus paper. In phenolphthalein, it will turn to pink. In methyl orange, it will turn to yellow. Calcium hydroxide, the red litmus paper will change to blue. No effect in blue litmus paper. The phenolphthalein will change to pink color in calcium hydroxide. Methyl orange will change to yellow color in calcium hydroxide. Similarly, for potassium hydroxide and for magnesium hydroxide, the phenolphthalein will change to pink and methyl orange to yellow, and similarly for ammonium hydroxide. So from this table we can observe that these four are acid. Okay, so red litmus paper has no effect on acid, but the blue litmus paper will change to red. Okay, the phenolphthalein is colorless in acid, but the methyl orange will turn to red in acidic solution. Okay, again when we look at these five, these are base in nature. So base, the red litmus will change to blue, but there is no effect by the blue litmus paper. The phenolphthalein will turn to pink color in base, and the methyl orange will turn to yellow color in base. So by observing this change in color, we can identify whether the given substance or the given solution is acid or base. Okay, so phenolphthalein, turmeric, litmus solution, litmus paper, red cabbage, China rose, methyl orange. These are some of the indicators, okay, that tell us whether a substance is acidic or basic by change in color. Okay. Alright students, we have another question. Please get your rough devices ready. The question is, which of the following is natural indicator? Okay, I'm giving you 15 seconds for this question. Your time starts now. Which of the following is natural indicator? Option A is methyl orange. Option B is eriochrome black. Option C is China rose petals. And option D is phenolphthalein. Alright students, your time is up, and yes, very good. The correct answer is option C, that is China rose petals. Very good students. Alright students, here we see a girl cooking in the kitchen. Yes, let us observe what happens. Now after cutting the onions, when she smells her hands, it stings. So she said to her aunt, "Auntie, my hands sting like onion." Okay, let's see what the aunt replied. Then the aunt replied saying, "Oh Rita, just wash your hands with some baking soda, the smell will go away." Okay, so the girl listened to her aunt and washed her hand using baking soda. Then the smell of the onion will go away. Okay, so there are some substances whose odor or whose smell change in acidic or basic media. Okay, such substances are called olfactory indicators. So far we have discussed about the indicators which change in color, right, which tell us whether the substance is acidic or basic by the change in color. But there are also some substance which tells us whether the substance is acidic or basic by the change in the smell. Okay, those indicators are known as olfactory indicators. So onion is one of them. So let us see. Here we see that onion retains smell in acidic medium and lose smell in basic medium. Okay, so when you put onions into an acidic solution and smell it, you can still have the smell of the onion. But when you put the onion into the basic medium, then the smell of the odor of the onion will go away. Okay, so in that way we can identify whether the substance is acidic or basic. Some examples of olfactory indicators include onions, vanilla essence, and clove oil. Okay, so these are some of the examples of olfactory indicators. So let us see hydrochloric acid. Take hydrochloric acid in one test tube. Take sodium hydroxide in one test tube. Add a drop of vanilla essence in both the test tube and smell it. Here we will see that it has tasty vanilla fragrance. Okay, the hydrochloric acid, when we add vanilla essence into the hydrochloric acid and smell it, we will still have the smell tasty vanilla fragrance. The fragrance of the vanilla can be smelled in hydrochloric acid. Now take the sodium hydroxide solution where vanilla essence is added and smell it. Okay, we will see that there is no smell of the vanilla from the test tube containing sodium hydroxide solution. So from here we can see that, okay, from here we can see that the vanilla essence, it retains its smell, okay, in acid, whereas it loses its smell in base. Okay, alright students, we have one more question. Please get your rough devices ready and respond to this question. The question is, which of the following is or are correct for olfactory indicators? Okay, I'm giving you 30 seconds for this question. Your time starts now. Which of the following is or are correct for olfactory indicators? One is their color changes with acid or base. Option 2 is onion, vanilla or clove are examples of olfactory indicators. So which of the following option is the correct answer? Only one, that is option A. Option B is only 2. Option C is both 1 and 2. And option D is neither 1 nor 2. Alright students, your time is up. And yes, we see that olfactory indicators, that color do not change. Yes, so option 1 is wrong. Onion, vanilla and clove are examples of olfactory indicators. So 2 is the correct option. So our correct answer here is option B, that is only 2. Okay, that is onion, vanilla or clove are examples of olfactory indicators. Very good students. Now let us see. Take clove oil, take hydrochloric acid in one test tube, sodium hydroxide in one test tube. Add some amount of clove oil into both the test tube and smell it. Let us see what happens. So here the man is surprised that the hydrochloric acid still has the smell of the clove oil. Now when he smelled the solution containing sodium hydroxide and clove oil, he found out that this test tube does not have the smell of clove oil. So from here we can say that the clove oil retains its smell in acid but it loses its smell in base. Okay, so olfactory indicators, let us see. The first we have is onion. Onion retains smell in acid but loses smell in base. Okay, the next olfactory indicator we have is the vanilla essence. Vanilla essence also retains its smell in acid and loses its smell in base. Then we have the clove oil. Clove oil also retains its smell in acid but loses its smell in base. Alright. Alright students, we have another question. Please get your rough devices ready. The question is, the example of olfactory indicators is option A is methyl orange, option B is onion, option C is blue litmus paper, and option D is phenolphthalein. So I'm giving you 30 seconds for this question, students. Your time starts now. Yes, students. The example of olfactory indicators is option A methyl orange, option B onion, option C is blue litmus, option D is phenolphthalein. Alright students, your time is up, and yes, very good. The correct answer is option B, that is onion. Methyl orange, blue litmus, phenolphthalein, they changes in color. They help us to identify whether the given substance is acid or base by the change in color. Only onion, okay, helps us to identify whether the given substance is acid or base by the change of the smell, right? By the change of the odor. So the correct answer here is option B, that is onion. Very good, students. Alright, students, so in today's class we have discussed about acids and bases, right? We have seen that acids are sour in taste and bitters are base bases are bitter in taste, right? We have also seen that there are different types of acids and bases that we can find. Yes, some are natural acids, they occur naturally in nature. Some are man-made. Yes, so for every acids and base we cannot identify whether they are acids or base by their taste. So we use indicators to identify. Okay, so what are indicators? Indicators are the chemical substances which help us to identify or which indicate whether the given substance is acid or base. Under indicators, we have discussed about two types. The first is the natural indicators and the synthetic indicator. Natural indicator includes, okay, or natural indicators are those indicators which occurs naturally in nature. It includes litmus, turmeric, China rose and red cabbage. These are just some examples of natural indicators. Okay, we have also seen how this natural indicator changes in acid solution and in bases solution. Yes, we have seen that in litmus solution the acid turns red. Okay, acid turns red and bases turns blue. Yes, we have seen that litmus paper, blue litmus change to red color in acid and red litmus change to blue color in base. We have also seen that turmeric in acid there is no effect, there is no change, but in base it turns to reddish brown color. China rose, we have seen that in acid China rose solution turns to dark pink or magenta. In base China rose solution changes to green color. Also red cabbage, we have seen that red cabbage solution in acid changes to red color and red cabbage solution in bases changes to green color. Okay, so these are some of the natural indicators. We have also discussed about the synthetic indicator. Synthetic indicators includes the phenolphthalein and methyl orange. We have seen that phenolphthalein in acid there is no change or it is colorless, but phenolphthalein in base it changes to pink color. Then methyl orange in acid it changes to red color and methyl orange in bases it changes to yellow color. So these are some of the natural indicators and synthetic indicators that we have discussed. We have also discussed that besides these indicators which help us to identify whether the given substance is acid or base by the change in the color, there are also some substances which help us to identify or which indicate whether the given substance is acid or base based on the change in the smell. Okay, the examples, these indicators are known as olfactory indicators, and the example of olfactory indicators includes the onion, vanilla essence and clove oil. Now we have seen that onion, vanilla essence and clove oil, they retains their smell in acidic solution and they loses their smell in basic solution. So these are some of the indicators that we have discussed today. Okay, I hope you are clear with what we have discussed today. Yes, students. Hello, dear students of Government High School Shovishe Memorial Zineboto. Hello, dear students of Government High School Shovishe Memorial. Can you hear me? Hello, dear students of Government Higher Secondary School Dipupar Dimapur. Hello, dear students. Hello, dear students of Government Middle School South Point East Zineboto. Hello, dear students. How was today's class? Do you have any doubts? Any question that you want to ask? Sure. So So you have learned
So you have learned
everything?
everything?
Yes, students?
Yes, students?
Alright, thank
Alright,
you.
thank
Thank you so
you.
much for
Thank you so
joining
much for
today's
joining
class.
today's class.
Alright, students, so this leads us to the last question for today. Please get your rough devices ready and respond to this question. The question is, how do you feel about today's class? Okay, I'm giving you 10 seconds for this question. Your time starts now. How do you feel about today's class? Kindly give your feedback about today's class. Alright, students, your time is up. Thank you so much for your response and thank you for joining today's class. I will see you again in our next class. Till then, take care everyone and have a nice day.